Hi everybody, in this video we are going to talk about measuring angles using a protractor, but before we can do that we need to know what an angle is. So, an angle is the amount of rotation between two lines. A full rotation is defined to be 360 degrees. So take a look at this picture over here. If I draw a line over here as my first line, then a full rotation would be defined to be 360 degrees. You can see that there's a little 360 over there. And that means half a rotation. So from here around to here would be 180 degrees. You can see there's 180 right over there. So a full rotation is 360, half of 360 is 180. So if we just went over to here, that would be 180 degrees. If we went only 1/4 of the way from here all the way around to here, then that would be 90 degrees. 1/4 of 360 is 90, okay, or you could divide 180 by 2 and you would get 90. So this is a 90-degree angle. That is called a right angle. A right angle is just an angle that is 90 degrees. It's the corner of a square. Okay, and then, you know, similarly for all these others. So it's, for example, if we only went from here to here, so this would be 1/3 of the angle that we had before, so 1/3 of 90 degrees. This right over here would only be 30 degrees. So we are measuring the amount of rotation between these two lines here, okay? The rotation between the two lines is an angle, and when we use a protractor, we're measuring that angle. So let's move on now. A protractor is used to measure angles, okay? Here is what a protractor looks like. All right, you can see that there's a flat part of it right over here. There's often something in the middle, a circle, or sometimes it's made with a line. It depends on, you know, different companies make different protractors. All the protractors look just a little bit different from each other. But then there would also be two sets of numbers. One set going this way. You can see that we go up as we go counterclockwise here, 0, 30, 60, 90, 120, 150, 180. Then the other side, the other set of numbers going up as we go clockwise, 0, 30, 60, 90, 120, 150, 180, okay? All right, so that's what a protractor looks like. All right, now let's talk about how we actually use a protractor. When measuring an angle, the vertex should be in the bottom center part of the protractor. The vertex is just where the two lines intersect. So remember, an angle is the rotation between two lines. The vertex is where the two lines meet. So this would be the vertex of these two lines over here. That's where they meet. Okay? So if we're measuring the angle between the two lines, then we want to put the vertex at the center bottom part of the protractor. All right, and one of the lines should be pointing towards one of the zeros. So you can see that this line over here, well, first of all, if we go back to what a protractor looks like, you can see that on a protractor, there are going to be two zeros. Here's one zero, here's another zero. You want to make sure that when you use the protractor, at least one of the lines is pointing towards one of the zeros. So over here, this line is not pointing towards one of the zeros, but this line is. This line is pointing towards this zero over here. Okay, so this protractor is being used correctly. The vertex is in the bottom center part of the protractor, okay? Vertex right over there in the bottom center part of the protractor. And one of the lines is pointing towards A0. There are two zeros here. This line is pointing towards this one. Now, it is actually possible to use a protractor where neither line is pointing towards one of the zeros. So you could have, let's say, this line pointing over here and this line maybe pointing over here, something like that. There is a way to do that, but let's just say that the proper way, if you will, the normal way to use a protractor is just to make sure that one of the lines is pointing towards one of the zeros. And we'll talk about the other method a little bit later. All right, so this would be wrong. Well, these two would be wrong. Improper maybe would be a better word, because for this one over here, it is actually still possible to figure out the measure of the angle, but this one is definitely wrong. So why is this one wrong? This one is wrong because the line is pointing towards one of the zeros, but the vertex is not in the center. We can see that the vertex, where these two lines meet, is not in the center, the bottom center part of the protractor. So that's why this one is wrong. So if you were using this protractor and you said that that this angle was, let's say, somewhere between 90 and 120, let's say you said that that angle was 100 degrees, let's say, well, you would be incorrect. That may be where this line is going, right? It looks like between 90 and 120 degrees. It looks like here would be about 100 degrees, but it was not set up properly to begin with. And anyway, it should also make sense to you that you're getting the wrong answer here, because if this is 90 degrees, let me do it how you're looking at it, okay? If this is 90 degrees, then that angle, which looks like it's smaller than 90 degrees, should not be 100, right? We shouldn't be getting an answer of 100 for that angle over there. And the reason we're getting that answer is because it's being set up improperly. This vertex is not positioned in the center. Okay, so why is this one wrong? The vertex is in the center. You can see the vertex is in the center there, but neither one of the lines is pointing towards a zero. Okay, this line is not pointing towards one of these zeros, and this line is not pointing towards one of these zeros. Now, this one is salvageable. It is still possible to figure out what the measure of this angle is by setting the protractor up this way. But like I said before, let's just say that this is not the standard way to set up the protractor. So that's why I'm saying it's wrong here, even though you could still figure out what the measure of the angle is. Okay, now there are two sets of numbers on a protractor. We already talked about that. So actually, you know what? I think I have a better picture. Okay. One set is written in a clockwise direction. Clockwise means moving in the same direction as a clock. So think of the clock on the wall of the school, on the wall of all the classrooms, which I know that you look at intently for the last 5 minutes of the school day, just hoping, oh, can we get to the end of the day already? All right, so think of how that clock moves. That clock would move this way, and that is called the clockwise direction. So these numbers over here are going up in the clockwise direction, and this set of numbers over here is going up in the counterclockwise direction. Counterclockwise just means the opposite direction that a clock moves. Okay, so clockwise means it moves in the same direction as a clock. All right, we talked about that. The other set is written in a counterclockwise direction. Clockwise means it moves in the opposite direction as a clock. Okay, so we talked about both of these. Okay, all right, and we talked about this and this as well. So which set of numbers should we use when we are using the protractor? Well, it depends on which zero the line is pointing to, okay? So we should always use the set of numbers that begins with 0. So take a look at this example over here. Let me just finish reading this actually. So we should always use the set of numbers that begins with 0. As we said before, there are 2 zeros on a protractor. Find which 0 the line is pointing to and use that set of numbers. So this line over here is pointing towards this 0. I know that the line is sort of covering the 0, so you can't see it, but this is where the 0 is. Okay, so as I move along here, I should be using this inside set of numbers because that's the set of numbers that starts with 0. So 0, 30, 60. So I would say that this angle over here is 60 degrees. If I had used the other set of numbers, then I might have thought that the angle was 120 degrees. But you should be able to see that that answer doesn't make sense, because think of acute and obtuse angles. I don't know if you learned earlier, but an acute angle is simply an angle which is less than 90 degrees. So this is 90 degrees. An acute angle is less than 90 degrees. An obtuse angle is more than 90 degrees. Okay, you can clearly see that this angle is acute. It is less than 90 degrees. So an answer of 120 degrees would not even make sense. So that's another way that you can figure out which one of these numbers to pick, is to just see if the angle is acute or obtuse. If the angle is acute, then you should use the number which is less than 90. And if you can see that the angle is obtuse, then you should use the number which is greater than 90. Okay, but you can also just start with 0, okay? So looking at this example over here, I see that this line is pointing this way, and where's the 0? The 0 would be over here, so we would use this set of numbers and follow this set of numbers until we get to the other line. So 0, 30, 60, 90, 120. So we can see that that angle over there is 120 degrees. If I had used this set of numbers by mistake, which started at 180, it didn't start at 0, then I would have said my answer is 60, but that 60 does not make sense. Why does that not make sense? Because this is an obtuse angle. This angle is clearly larger than 90 degrees. This is 90, remember. That angle is clearly larger than 90. There's more than a 90-degree rotation between these two lines here. So an answer of 60 does not make sense, but an answer of 120 does make sense. So again, you can figure out which number to pick based on if the angle is obtuse or acute, if it's greater than 90 degrees or less than 90 degrees. And you can also, but you should also know that you should be using the set of numbers that starts with 0. So see where this line is pointing, find 0, and then follow those numbers up to this other line over here, okay? All right, so what I'm going to do for the rest of this video is I'm going to practice just measuring angles. Let me get these ads out of the way. All right, whatever. So I have an angle over here. I have two lines. What we want to do is we want to measure the amount of rotation between these two lines. So the first thing is we will make sure that the vertex over here is centered on the bottom center part of the protractor. So I'll move this over to here. And then I also want to make sure that that this 0 here is lined up with one of these lines, okay? So there we go. And now to measure the angle, I'm going to follow the set of numbers that starts with 0 up to this other line over here. And I see that this is 10, and this is 20. Remember, I'm using this set of numbers. And then, so this would be 10 over here. We can see that it's somewhere between 10 and 20. To see exactly what it is, now I have to look at these smaller lines over here on the edge. So I'm still using this set of numbers, but I have to sort of continue them. So 10 would be over here, 20 would be over here, and then in the middle here, this would be halfway between 10 and 20, which is 15. And then this is moving in the positive direction as we go this way. So it looks like it's one space further than 15, which would be 16. So this angle is 16 degrees. Let's look at another example. There's a fun face over there. Okay, so let's get this vertex on the bottom center part of the protractor. Now let's just adjust the protractor so that this line over here is going through 0 over here. So I want to start with 0 and use this set of numbers, follow this set of numbers up until I get to the line. And it looks like this line is going exactly through 90 degrees. So this is a 90-degree angle there. Okay, let's do another example. We're gonna do how many? We're gonna do 7 examples. We're on number 3 now. Okay. First things first, we're going to get our angle on the We're going to make sure that the vertex is over the bottom center part of the protractor. We're going to make sure that a line is going through 0. It does not have to go through this 0 over here like in the last couple of examples. It could also go through this 0 over here. So let's line that up. Okay, so now it looks like before we were using the inside set of numbers. For this one, we're going to use the outside set of numbers because here's 0 over here. So we're using the outside set of numbers now, 0, 10, 20, 30. Okay, so if this is 30, this is 40, then this line over here, it would be 35, halfway between 30 and 40. And then this would be 36, and this would be 37. So this angle would be 37 degrees. All right. Let's look at angle 4. We're going to get the vertex line, okay, bottom center part on the vertex. And now this line over here is passing through this 0. All right, so following this set of numbers over to this line, it looks like this is going, let's see, 140, 150, so this is 160 over here. And it looks like, you know, let me, just because I can't see that a little bit. Yeah, so it looks like this is just about exactly 160 degrees. Okay, so that one is 160. Now, and notice that another way that we could have figured that out is just to reason this way, that this angle over here, which is pretty big, that's clearly bigger than 90 degrees, which is this. Okay, so an answer of 20 degrees would not make any sense at all. 20 is not bigger than 90. So it has to be, out of these two options here, it's got to be 160. Okay? Again, if we have an obtuse angle, then it should be more than 90. If we have an acute angle, it'll be less than 90. That was, which angle was that? Was that 4 or 5? I think that was 4, right? Okay, now let's do angle 5. Okay, this line over here, well, this is a straight line. So Really, it's two lines, right? We have one line like this, and then, oh my goodness, look how straight I did that. That was freehand. Up until the end, I was doing it perfectly. So that's one of the lines, and then the other line is going this way. So really, this is two lines, but they're lined up perfectly. So they sort of become one line, and we're measuring the rotation between them. So again, we're going to get the bottom center part of the protractor over the vertex. This would be the vertex here. Now we have our choice between which zero to use. No matter which zero we use, in this case, because both of these lines are going through a zero, we'll get the same answer. So if we start with this line is going through this zero, then we follow this over and use the outside set of numbers, we would get to 180 degrees. If we follow this line over to the zero that this is going through and then use this set of numbers, then we also get 180 degrees, okay? So this angle is 180 degrees. When we see a straight line, that's 180 degrees. That's half of a full rotation. A full rotation all the way around a circle would be 360 degrees, and then halfway around the circle would be 180 degrees. That was number 5. Okay, 2 more. This one confuses a lot of students. See if you can figure out what you should do with the protractor. So I know that a lot of students, they'll get this part right at least. They'll remember to put this part of the protractor over the vertex. Then what do we do? Okay, well, all you have to do is turn the protractor around. All right, I'm gonna have to move this down a little bit just because I can't reach the part that lets me turn it. Oops, oh. Okay, but all we have to do is twist the protractor around. Now, a lot of students will twist it around up to this point. So then they'll try to measure it like this. This is no good. You can't measure it this way because, okay, this line here is going through 0, but this line is not going through any of the numbers here. So that's no good. We're not going to be able to measure the angle that way. So let's continue turning this. Okay, that's all. There we go. So now we have the vertex over the bottom center part of the protractor. We have this line over here going through 0. So we're going to use this set of numbers over to here, to that other line. Okay, so we're using this set of numbers using the outside set of numbers. So 0, 10, 20, 30, 40, 50, and then let's see here. So this is 50 exactly. This would be 51, 52. Looks like that is 53 degrees. All right, so this angle is 53 degrees. By the way, the rotation between here, so this is 53 degrees over here. What about from here to here? What's the rotation there? That's also 53 degrees. What about from here around to here? That's also 53 degrees, okay? It doesn't matter what part of the line I start at. The angle between the two lines for this entire thing is 53 degrees. All right. Let's go to the last example. Oh, and then remind me when I get to the end. I have to show you that other way that I said was okay to use the protractor, even though it doesn't start at 0. All right, so how could we do this one? Let's bring the bottom center part of the protractor over the vertex. And then sort of at the same time here, I'm also making sure that one of the lines is going through 0. Okay, so let's use this set of numbers around to here. So this over here is 10, and this would be 9. So this is 9 degrees. Okay, now let me actually use one of the angles that we did earlier. I'm just trying to think of which one would be the easiest to use. Let's go back to the very first one. Okay, so we did this one already. And we said that this was 16 degrees, right? Now, what if you had made your protractor go like that, so that neither one of these lines is going through 0? Is it still possible to figure out the measure of this angle? We still have the vertex over the bottom center part of the protractor, so that part is good, but neither one of these lines is going through 0. Can we still figure out that this is a 16-degree angle? Yes, we still could do that, actually. And in some IXL exercises that I'm going to assign, it's going to set up the protractor like that, and you have to figure out what the measure of the angle is. So that's why I'm talking about this now. Now, the way to do that is to actually choose any set of numbers, either the inside set of numbers or the outside set of numbers, and subtract. Okay, subtract where both of these lines are going through. There, I didn't say that very well. So let me show you what I mean. So this line over here is going through what? This would be, let's see, if this is 40, not 140 here, I'm using the inside set of numbers right now. So if this is 40, then this would be 41. We can see we're going up this way, 10, 20, 30, 40. So if this is 40, then this would be 41. So that's 41 there. This line over here is going through, looks like it's going through 25. If this is 20, this is 30, then this is exactly halfway between them. That is 25. So all we would have to do is subtract these numbers. In other words, if it is 41 degrees from here around to here, and it's 25 degrees from here around to here, then how many degrees is it from here to here? If this is 41 and this is 25, the way to figure out what this is to subtract 25 from 41. And if we do that, then we would get 16, which is what we said in the first place, that was a 16-degree angle. Now, we use the inside set of numbers there, but we actually could have also used the outside set of numbers. If you're using that strategy, then it really doesn't matter which set of numbers you use. So if I use the outside set of numbers here, then this over here is 140. What do you think this is? Would this be 141? No. Why not? Because you can see that the outside set of numbers goes up as we move this way. 110, 120, 130, 140. So this would be 141 over here. This would be 139. So we have 139 degrees over here. Oops, 139 degrees. This over here, remember, we're going up this way. So 120, 130, 140, 150, 160 over here. This is exactly halfway between 150 and 160. So that would be 155 degrees. And we could use that same reasoning that from here around to here is 155 degrees. And from here around to here is 139 degrees, then what's the measure of the angle from here to here? It would be 155 minus 139 to figure out what the difference between these two is, right? So we would do 155 minus 139, and I can't take 9 away from 5, borrow from the 5, that becomes a 4, put a 1 next here, 15 minus 9 is 6, 4 minus 3 is 1, 1 minus 1 is nothing. So again, we get 16 degrees, okay? So that's another way we could figure it out. All right, I think I'm going to end the video there, and have a great day.